Okay, come back to that now, right? The Cy to 4 minus is the ratio. Okay, so alpha 4 is ratio and the pH dependent. Then you calculate this. Then alpha 4 is somewhere 0.4 something. Okay, so this is the total left behind at equilibrium. So a portion of that is that. Okay, so this is going to participate to this equilibrium expression. The rest will not. Only Y4 minus will participate in this expression. Okay? So it's going to be written like this. Okay, envision a real calculation now. Okay, another envision. So it's always imagine doing the real thing. It's easier to understand, right? Okay, so imagine now you have this solution. Calcium chloride, 40 mils, 0.01 molar. And here 60 mils of EDTA, also 0.01. Okay, you mix the two and put buffer to maintain 10. Then I will ask you, in the mixture, what is the calcium 2 plus concentration? Then what is the complex concentration? Okay, for some people, looking at this, will jump into calculation. What's the problem? This is easy. So MV of that over the total volume is the concentration, right? So you might think that MV then over 100 is the concentration. Wrong, right? Don't forget, there is going to be chemical reaction. You are not simply diluting that solution, okay? That actually happened on an exam question that, some people answer with the wrong one and get 2 points out of 10. Okay, so this is a concentration at equilibrium. So after reaction, how much is free? Okay. Then this complex, this one is a product through chemical reaction. So again, it's at equilibrium. So the Kf is provided, then the pH is provided. So now, draw your common sense. Look at the K value is huge, 10 to the 10. So whatever for chemical reaction for product is based on the limiting agent. So you do the easy calculation first. So calculate for the complex, right? The complex concentration will be equal to all the limiting agents that's reacted. So you have only 2 chemicals. Which one is limiting? Well, calcium, right? So all of that will be complex, right? So K is large, all of that complex. So what is the quantity of the limiting agent? Is MV, calcium, over 100. So here is equal to the concentration of the complex. It's not the concentration of calcium 2 plus. Okay, so this is the correct answer in your final product. Any question for this one? Now this one is easy. This one is a little tricky, lengthier to calculate. Well, because this is a limiting agent, it's all reacted, right? Then your answer could be, for some people, you say 0, none. Okay, then you get 1 point out of 10 for the 1. I mean for the 0. Yeah, it's all reacted. But then you can calculate the tiny quantity, by realizing something like this happened, right? We are talking about equilibrium. So it's the K, it's a 2-way arrow. So now you generate all products. But then what about a reverse arrow? That means a tiny bit is going to dissociate. So it's minus X from the product. So now, even though it's all reacted, 0. but then you got a return of the tiny bit, you're going to add to it. So 0 plus x. So now your mission is to how do you calculate that x. Okay, so this x is for your calcium, 2 plus equilibrium. Now, it's not a piece of cake, or cannot say that, or it's not too straightforward to calculate the little x, the calcium. So you need to have an understanding the concept of equilibrium. So you need to know what is 4y minus 4 at equilibrium, because your k expression requires that concentration, right? Okay, so back to what Chris' question, he raised, which is an excellent one, that here exercise your true understanding. Okay, all your EDTA, right, can be calculated. Analytical concentration is MV, right? You prepare 60 ml. In a mixture now, all your EDTA should be of this concentration, right? So now all the EDTA is going to distribute it among all these species, right? So the species being the complex, which we had calculated the amount previously. So this number we know, right? Just from the previous slide, you can transfer that number to here. So the difference between the two, so this total, subtract that, is equal to Cy at equilibrium. So this Cy represents how much is left at equilibrium in a mixture. Okay, so this Cy becomes a numerical value total, right? Okay, then what about this total? The fraction of this total belongs to Y4 minus. So this is one species at equilibrium. So alpha 4, right, the previous one, alpha 4, pH 10. So 10 to the minus 10, again, you get the alpha 4. Okay, and this is a numerical value. So the two multiply each other, you get a quantity of 4 minus at equilibrium. Right? Bingo, right? So you get this quantity. So now you can picture the real deal. Okay? So this represents how much excess of the EDTA in solution, the total. Okay, the total, a portion of that is this. So now the equilibrium expression can be used. Yes?
Can you go over one more time where you got the value for Cy from?
Okay, very good question. So this one, we just calculated it previously. Mm-hmm. And this one is the analytical concentration you can calculate. The difference between the two, right? This one, of course, is larger.
Right.
Going to subtract this one, then you end up with Cy.
You just have to multiply by alpha.
Alpha 4.
Got it.
Yep. Cool. Multiply the two. This is how you get this. Okay. So once you have this, then you can plug in the equilibrium expression. Okay. This is the equilibrium expression as written. You do Kf. Okay. So now the complex has a numerical value. You calculate it, check. Okay. Then here, the y minus 4, calculated, check. So leaving behind at equilibrium is this guy, unknown, right? So set that up to be equal to Kf. So equilibrium is, well, not 0, but it's really small, 10 to the minus 10, right? Okay, then you get 10 points out of 10. if you give me this answer. Any question? Yes, Chris?
Alpha 4 is a table value for pH -10?
Well, you may use the table value, or I ask you to calculate for the alpha 4.
Oh, that's right.
Right? So I had calculated it, or I had looked at the table value.
Alright.
So
But on
I
the test,
multiply
you
the
give us
two
table
and end
value
up with that,
Because it takes us like an hour and a half to get.
an hour and a half.
Right.
Uh,
Well, you'd give us the table value, or that would be the only question on the test, right?
Depends on what. You know, in case of I stress for this calculation, then I give you the alpha 4. If I stress for alpha 4 calculation, then it will be calculated alone, standalone question, you know. You know the shortcut, relative magnitude, right? The formula can be reduced to a simpler one, right? Because some contributions are negligible that you can ignore, you know, the K values and all. So exercise that. Time is precious during an exam. Okay, so this is how you get it. Question? Okay, Nassim? You have any question?
Not really.
Okay? Ryan?